Welcome. In this video, we are going to discuss about previous year NEET question in the year of 2004 in physical chemistry under the topic of some basic concepts in chemistry. In this year also only one question is asked. Let's discuss this. The maximum number of molecules present in the four option is given. Among these four, which one contains number of, which means maximum number of molecules? Okay, molecules, not a moles, maximum number of molecules. How to find molecules? That is our first step. Okay, always there is a formula to find number of molecules. Okay, what is the formula? The number of molecules which is equal to number of moles multiplied by Avogadro's number. Okay, Avogadro numbers are constant. There is no worry about the Avogadro's number. Okay, our main task is to find the number of moles. Among the four, which one have number of moles? That is have the number of molecules, because Avogadro's number is constant for all the four options. Okay, we need to find the number of moles. Which has the highest number of moles? That has the highest number of molecules. That's it. Okay. In the first option, 15 liter of H2 gas at STP. STP, which is nothing but STP is nothing but a standard temperature pressure at this condition, which means standard temperature is nothing but 25 degrees Celsius, and pressure is 1 bar pressure, or else one atmosphere or 1 bar, everything is same. Okay. 1 atmosphere or 1 bar. Okay. In this condition, every gases, here it is also gases. Okay, kindly note, at the standard temperature pressure, which means 1 bar under 25 degrees Celsius, every gas occupies 22.4 liter of volume. What is 22.4 liter of volume? 22.4 liter of volume, which means it occupies 22.4 liter in 3-dimensional. Okay, volume is nothing but an object occupies a space in the 3-dimensional. I am repeating, volume is nothing but an object occupies a space in 3-dimensionally. If I am sitting in a chair, I am occupy the space in that chair. That is my volume. Okay, this is the difference between volume and mass. Mass means how much I am weight, which means by the gravitational force how much I weight on this earth. That is a weight. But volume is nothing but how much space occupied by me in this 3-dimensional. Okay, right. So I think this is clear. Okay. Then how to find the number of moles from this? Okay, 15 liter at STP, which means it is nothing but 15 divided by 22.4. It is nothing but a hydrogen gas should be occupy 22.4 liter, because 1 mole, right? I'm already told 1 mole of gas occupies 22.4 liter in STP. I have only 15 liter. Then take ratio. We will find the, then we will result in the number of moles. If I take ratio between 15 liter to 22.4 liter, I will get the number of moles. Okay. 15 divided by 22.4, it will result in 0.6696, which means 0.6696, 0.6696. This is in the first option. Okay, I'm arranging something to make this clear. Okay, because this is so. Okay, okay, then okay, right. In option A, the number of moles is nothing but 0.6696. Likewise, do the same thing for option B. It is also 5 liter in STP. 5 liter, which means 5 divided by 22.4. I am taking the ratio between 5 and 22.4 liters. Then so that I will find how much moles of nitrogen gas is there. Then 5 divided by 22.4, it is nothing but 0.2232. Okay. Then option C is nothing but a gram. Okay. It is nothing but a given gram. It is very simple, and we already solved this type of problem many times. To find number of moles, it is nothing but given weight divided by molecular weight. Given weight is 0.5 for the third option. Molecular weight of H2. Okay, kindly note this is H2. For hydrogen it is 1. H2 it is 2. Molecular weight is 2. Okay, then 0.5 divided by 2, it will result in 0.25. 0.25. This is the number of moles in this case. Then what about oxygen? Given weight is 10, molecular weight is 16 plus 16, it is nothing but 32. Then 10 divided by 32, it is nothing but 0 0.3125. 0 0.3125. Which one has higher value? That is the answer. This is 0 0.3, 0 0.2, 0 0.2, then this is 0 0.6. Then this has higher moles. Then this should have the maximum number of molecules. Okay, this is the right way to solve this question. Kindly note, at STP, every gaseous molecule, which means 1 mole, that word is very important. 1 mole of gaseous molecule occupies 22.4 liters in three-dimensional space. If it is not occupying the 22.4 liter, it is not 1 mole. Then what liter it occupies? It can be 15, 5, anything. Apart from 22.4, it can be anything. Then take the ratio between that anything and the 22.4 liter. We will find the number of moles from that. Okay, that is a key.